we are going to discuss about system with friction or principle of friction. So, whenever one of the blocks moves or tends to move with respect to the surface on which it rests, the interlocking property of the projecting particles opposes the motion. That opposing force is called as force of friction or simply called friction, right. See, whenever the surfaces of two bodies are in contact, there is a limited amount of resistance to sliding between them, which is called a friction, right. This friction, this force is distributed at the surfaces of the contact and acts tangential to the surface of the contact, right. Or in some other words, it is a resistance offered by the surface that are in contact when they move past each other, or in some other words, the friction is the force that resists motion when the surfaces of one object comes in contact with the surface of another, right. See, normally the frictional force is acting opposite to the direction of the force, right. See, this is the block and the force is acting towards right side and the frictional force is acting towards left side. This is frictional force, right. So, this is the force applied to the body, right. Now, types of frictions. So, types of friction is generally divided into static and dynamic. This is static friction, which means the two surfaces which are in contact or at rest position always, that is for example sofa, right. See, the force of friction, I mean the force experienced by one surface called, it is a static friction just generally, whereas for dynamic examples bus, tire and road, right. Again this friction is divided into two, one is sliding friction, another one is rolling friction. This dynamic friction is divided into two, sliding and rolling. So, sliding, which means the friction experienced by a body when the body slides over the another body, right. So, like this, there is no wheels, whereas the rolling friction, which means the friction experienced by a body when it rolls over the another body, right, with wheels, right. And generally types of frictions is dry friction and limiting dry friction and lubricated friction or fluid friction, right. So, dry friction, types of friction generally dry friction and fluid friction or lubricated friction. Dry friction is nothing but when the unlubricated surfaces of two solids are in contact under the condition of sliding. So, that is dry friction, whereas for fluid friction, a thin layer of oil between the two surfaces or two bodies, then that is called as a fluid friction, right. Next, the limiting force of friction. The limiting force of friction is nothing but the maximum force, the maximum frictional force developed at the surface when the body begins to move, right, or the maximum force, frictional force that comes into play when the body just starts moving in the limiting condition of static friction, right. See, this is the body and the weight of the body is acting towards downward, that is called as W, and the normal reaction is acting upward, N, and the force which is called thrust towards acting right side, and the limiting force of friction is acting left side when the force P is greater than F. So, at that point where the frictional force is less than the pulling force, that is called as the limiting force of friction, right. And law of friction is nothing but the direction of frictional force, which is opposite to the direction of the motion of the body. Say for example, this is the body and the body is sliding over the surface and W is acting downward and the normal reaction is acting upward. This is the direction of force and the friction is always opposite to the direction of the force. So, that is the first point. The first point which is the direction of force. The direction of frictional force is opposite to the direction of motion of the body. The second one is the force, the frictional force is independent of the area of contact and depends on the type of contact, which means nature of contact, right. See, say for example, frictional force is directly proportional to the normal reaction, right. In order to remove the proportionality, F which is equal to mu into N, right, mu which is equal to coefficient of friction, right. one more time, the second point, which is the frictional force is independent of the area of contact and depends on the type of contact or the nature of contact. The third point, the magnitude of frictional force F, which is equal to the force tends to move the body, magnitude of force. So, F which is equal to P, right. So, these 3 points are very important, that is called as the law of friction. The next one is the angle of friction. The angle of friction is nothing but the angle made by the resultant of normal reaction and the limiting force of friction with the normal reaction. Say for example, this is the plane and the body is sliding over the surface, it is resting, actually the body is rest on the plane, and W is acting towards downward and normal reaction which is acting upward, right. So, the force applied force which is acting towards right side, then the frictional force which is acting opposite direction, right, and this is called as W, right. Say this is the body and the normal reaction, I mean Rn, which means normal reaction, or else we call N, right. So, both are same, then the acting W, and this is called as P and this is F, right. So, here the frictional normal reaction is acting upward, this is Rn, and this is called as force applied, frictional force F, right, frictional force F, and the resultant which is called as S or R is not notation is S is okay, right. This is resultant, right, resultant force. The angle between these two, see, say for example, this is the normal reaction Rn and the frictional force is acting this side, and the resultant of the normal reaction and frictional force, this is S, right, and the angle made by the resultant of the normal reaction and frictional force with the normal reaction, that is called phi. This phi which is called as the angle of friction, phi, right, angle of friction, angle of friction. So, here tan phi which is equal to F divided by Rn, right. So, angle of friction tan phi which is equal to opposite by adjacent Rn, right. So, here F which is equal to tan phi which is equal to F into Rn. We know that F is equal to mu into Rn. In the previous slide we discussed force of friction which is equal to mu into Rn, right. So, substitute here. So, tan phi which is equal to mu into Rn divided by Rn. So, Rn cancel. So, tan phi which is equal to mu. So, this is the equation we got finally, right. Mu which is equal to coefficient of friction, already we discussed, coefficient of friction, right. Next, so already we discussed coefficient of friction mu. So, we know that F which is equal to mu into Rn. So, mu which is equal to the ratio between force into normal reaction, right. So, mu tan phi which is equal to mu, already we discussed, right. So, instead of that substitute tan phi, that is it. So, tan phi or mu which is equal to force divided by Rn, this is the formula we got, right. So, phi which is equal to angle of friction and F which is equal to limiting friction or frictional force, N which is equal to normal reaction, right. It is a simple problem. We will discuss. A body of weight 100 Newton is placed on a rough horizontal plane. Determine the coefficient of friction if the horizontal pulling force of 60 Newton just caused the body to slide over the horizontal plane, right. So, this is the body and the body is sliding over the flat surface or horizontal surface, right, which is a pulling force of 60 Newton. So, this is the pulling force 60 Newton and W is acting downward and normal reaction is acting upward Rn, and so this is the direction of pulling force and the force frictional force is acting opposite direction. This is frictional force F. Now we need to find coefficient of friction mu, right? They are asking what is the value of mu, right? So first we need to equate vertical forces which is equal to 0, sum of vertical forces which is equal to 0. How many vertical forces are there? Rn is acting upward, W is acting downward, right? So R a normal reaction which is equal to W. W given in the problem 100 Newton. So what is the value of Rn? Rn which is equal to 100 Newton. So this is equation 1, right? Then now equate sum of horizontal forces which is equal to 0. Now horizontal forces how many? Frictional force is acting left side and the pulling force 60 Newton is acting right side. So both are in the opposite direction. So F which is equal to 60 Newton, right? So we know that F which is equal to mu into Rn, right? So F which is equal to 60 which is equal to mu into Rn which is equal to 100 Newton, right? So mu which is equal to 60 divided by 100, so which is equal to 0.6, right? So coefficient of friction mu which is equal to what is the value? 0.6, right? Is there any unit for coefficient of friction? No, because 60 Newton and 100 Newton, so Newton cancel, there is no unit for coefficient of friction, right? Thank you.